With this in mind, how about that we take all the code that we've just written and move that into a new anonymous method that we pass into task.run. This will queue the code to execute on a separate thread. Unless the thread pool is too busy, this should start off immediately. The whole purpose of calling task.run is to start work without locking the current thread or the context. This is totally awesome. There are a few problems though. When you run the application, it will tell you that it took 0 milliseconds to load all the data. In reality, we know that it doesn't. A bigger issue is that it didn't populate the data grid with any data. This is an indication that something might not be working as it should. If we run this application with the debugger attached, it will tell you why this didn't work. An exception is being thrown because we are trying to update the UI from a different thread than the UI thread. The object that we are trying to access is owned by the UI thread, and the task is running on another one. We need a way to communicate with the UI thread while still allowing for the majority of the heavy work to run on a separate thread. Coming from the previous module, you'd probably want to add the async and await keywords. But let's try to solve this without introducing them. There's another way for us to queue work on the UI thread from the task. In WPF, you can use something called a dispatcher, and it has an invoke method to queue and run the work passed to it on the UI thread. In WinForms, Xamarin, and other UI frameworks, there are similar ways to do this. Under the hoods, this builds on something known as the synchronization context. Even in non-UI applications, you have ways to communicate across threads. When converting synchronous code that we've just looked at into asynchronous code, we need to make sure that the code that we have inside our asynchronous version don't queue any heavy work on the UI thread. This would ultimately defeat the purpose. As an example, don't execute long-running operations using dispatcher.invoke. You want to be able to pretty much guarantee that what you pass to a task.run don't necessarily go back and block the UI thread. When we search for a stock now, the application behaves much better, and after a little while, all the data is available in the data grid. There's a small bug in the application. It's still giving us the incorrect amount of milliseconds it took to load the data. I know for a fact that it took much longer than what it's telling us. What happens here is that the task scheduler will queue this work onto the thread pool, and it will just execute that whenever there's an available thread. The call to task.run will therefore complete immediately, as the work is being sent somewhere else. Therefore, the next line will execute, and the timer that calculates how long this operation took will fire off straight away. Don't worry, we'll fix this. If you already have an idea on how to solve this, I'd recommend pausing the video and giving that a try. To make sure that the code after task.run only execute once the asynchronous operation has completed, you by now know that you have to introduce a continuation. You've hopefully watched the previous module and know that we can now introduce the async and await keywords. Don't worry, in the next clip, we'll explore how to do this without using async and await. To summarize what happens in this code block, we queue all the work to be executed somewhere else, and when we are notified that the work is done, we go ahead and run the code after the await keyword. This will give the user a pretty good experience. Once all the data is available, we'll populate the data grid, and you can continue to take notes as the data is being loaded. While the application behaves similar to what we did at the end of the previous module, we've now introduced an alternative way to execute something asynchronously, especially given the fact that the code block that we converted was previously synchronous and locked up the entire application. You saw how easy it is to introduce the task, to schedule work to be executed somewhere else. In a lot of cases, you might have code that takes a little bit of time to run, or use libraries that don't expose asynchronous versions. In these cases, this is the perfect fit for where to introduce task.run to execute code in an asynchronous operation. You're now also familiar with how to combine your own task with the async and await keywords. While async and await makes the process of creating a continuation and obtaining a result much easier, we'd still like to explore how to do this just using the task. So let's explore that in the next clip.